Okay, and so one thing about the way that I'm going to show you how to solve equations is I'm going to do it the exact same way every single time, no matter if there is a simpler, shorter trick way to do it, because I find that if I teach students tricks, they apply them in the wrong situation, and then we get things wrong. So I'm just going to do it the exact same way every single time, and there is an easier way to do the ones in this lesson than the way that I'm going to do them, but I'm doing it the way that I'm doing it so that I can show you a way that will always work no matter what is happening with the equation. And this will be something that comes up in the next lesson. And so I wanted to make sure that I'm being consistent with the way that I'm teaching it. So the first thing you'll notice is that I wrote this differently than the way you see it in ALEKS. And that's because when we have two fractions that have the same denominator, it's a habit to put them over one denominator. And to me, this looks very confusing because it's like, well, why is there only one number down here and there's two up there? What's really going on is that's really x over negative 9 plus 63 over negative 9. They just stuck them together and then put the denominator there like that, which I personally do not like. And so I'm not going to do that. I'm going to separate them out so that I can really see what's going on with them. Okay, and so as we've done in previous lessons, we see that our denominator is negative 9. We don't like that. We are going to multiply both sides by negative 9 to make it so that the denominators will divide out evenly. So we'll get negative 9x over negative 9 plus, that's a huge number. Don't freak out when you see the size of the number. It's not going to matter. 567 over negative 9. Negative 8 times negative 9 is positive 72. Now the magic happens when we do the division here on the left, and we see that those fractions are going to disappear. So we've got as negative 9 divided by negative 9 is 1. Leaves us with x. 567 divided by 9 is going to be 63, negative 63. And that's equal to 72. We should clean the signs up there on the left. We do have a plus, a minus, which is going to make x minus 63 is equal to 72. Pause for one moment. I noticed that I made a mistake with my signs, so I need to fix that. That's a negative 567 because negative 9 times positive 63 is a negative times a positive makes a negative. So I need to fix a little bit here. We would have negative 9 divided by negative 9 is 1. Negative divided by negative is positive 63. Okay, and so what we're going to have to do next, we see that 63 is being added to x. We're going to subtract 63 from both sides. And we're going to get x is equal to 9. All right, next we have x over 5 plus 33 over 5. And again, I'm writing this differently than they do in ALEKS because I want to really see what's going on and not shove those numerators together over the same denominator the way that they did. All right, and so what I see is that I have a denominator of 5. And so I want to multiply both sides by 5 so that that denominator will divide out evenly. And what we've got is 5x over 5 plus 5 times 33 is 165 over 5. And 5 times 5 is 25. So 5x divided by 5 is going to leave me with just 1x. 165 divided by 5 is going to be 33 is equal to 25. We see that we have 33 on, adding 33 on the left, we need to subtract 33 from both sides. We get x is equal to negative 8. Okay. We have 5 is equal to 3x over 2 plus 22 over 2. Our denominator is 2. We're going to multiply both sides by 2. It's going to give us 10 is equal to 6x over 2 plus 44 over 2. Now the beauty of this, even though this looks nasty now, is those fractions are going to divide out evenly. We get 10 is equal to 3x plus 22. Now all we need to do is subtract 22 from both sides. It's going to give us negative 12 on the left, a 3x on the right. We see we're multiplying by 3, so we need to divide by 3. We get negative 4 is equal to x. We'll do a couple more. We have x over 5 plus 19 over 5 is equal to 3. I will choose to multiply both sides by 5. Because I know that will allow the fractions to divide out evenly. So I've got 5x over 5 plus 95 over 5 is equal to 15. We're going to see that those fractions will come out to be whole numbers now. So 5x divided by 5 is x. 95 divided by 5 is 19. And we're still equal to 15. So we have x plus 19 is equal to 15. All we need to do to isolate the variable is to do the inverse operation of adding 19, which is subtracting 19. We get x is equal to negative 4. And we'll do one more. We have x over negative 8 plus 54 over negative 8 is equal to negative 8. We'll multiply both sides by negative 8. And we will get negative 8x over negative 8 plus, get my calculator just to be safe here, 432, and it is a negative 432 over negative 8 is equal to positive 64. Now, simplifying these fractions on the left, we end up with positive x plus 432 divided by 8 is 54. It's positive because a negative divided by a negative makes positive, and that's equal to 64. We're going to subtract 54 from both sides, which is going to leave us with x is equal to 10.